Hello, Nick. How are you? Your mic is off, I think.
Hi. I'm very good. Thank you. Thank you for having me here.
Okay, so if you are ready, the stage is yours.
Thank you so much. So, hi everybody, and welcome to my talk today. I'm going to talk to you about Jetpack Compose. So Jetpack Compose is Android's modern declarative new UI toolkit. It's a complete rewrite of the existing toolkit that we have, the View system, which has been around for 10 years and is kind of starting to show its age. So I'm very excited about what a new approach to this is going to be like. One thing I'm extremely excited about is that it's built entirely on Kotlin. It's actually built as a compiler plugin to the Kotlin toolchain, which really embraces the very kind of expressive and terse and productive qualities that Kotlin give you. If you're like me, you'll love writing Kotlin code, and Jetpack Compose feels right at home on a lot of the Kotlin idioms. Compose is also unbundled, which means it's a library you include in your application. This gives us support all the way back to API 21, Lollipop, and it means you can adopt it at your own pace, taking updates as and when you would like to. Compose actually targets the canvas, the Android canvas system. So it doesn't actually output views under the hood, it writes to a canvas. And as such, we can get the same behavior across all of those API versions. So there's less of this different behavior on different APIs, which is great. But for me, one of the most exciting things about Compose is that it makes Android UI, building Android UIs easier. I love building Android UI, but you know, I won't lie and say to you that it's the easiest thing in the world. And Jetpack Compose is really an opportunity to make this much, much easier for you. And not only easy, I actually think it makes the easy things easy, but it also makes things which were really impossible or very hard to do in the old system much, much easier or possible even. But don't just take my word for it. Today in this talk, I'd like to show you what I mean by this and actually take you through some examples of UIs that we have built ourselves in order that you can learn Compose by looking at some examples. So we have for a while had a single example app out there on our GitHub repo, which was called Jet News. But we've recently added to this family. So now we've added an extra 4 Jet apps. So there's a kind of chat type app called Jet Chat and a survey type app. Each sample application explores different use cases and showcases how to build different kinds of UI. There's a couple more advanced samples here, Jetcaster and JetSnap, which show a lot more advanced kind of theming use cases as well as animation. In addition to that, we've added 3 of the material design sample applications, which showcase how to get the most out of material. So all in all, we have these 8 sample applications showcased here on this GitHub repo. And this is what I'm going to draw from today. I'm going to take you through some examples of UIs we've built in these sample applications to show you what Jetpack Compose is all about and what it can do for you. So let's jump in. There's a lot I want to get through today. The first thing I'm really excited about is the way that Jetpack Compose approaches theming. In particular, the OWL sample app has a very kind of varied use of theming. It uses these like completely different color schemes in different sections of the application, and each of which there's a dark theme for it as well as a light theme. So there's a lot of different kind of theming going on. This sample uses material theming, which if you're not familiar with it, it's a way of customizing material to bring your own kind of brand, your own look and feel. It lets you customize things like colors, shapes, and typography, and changing configuration for those 3 kind of systems updates all of the components in your application. So Jetpack Compose ships a implementation of the material design system. It models this using this function here, this material theme function, which accepts parameters for color, typography, and shapes. Those parameters are typed, right? So the color system, for example, is modeled using this colors data class type object, which has properties for each of the kind of named colors in the material color system. There are builder functions to help you build this, so you can just have to provide the ones that you want to customize and accept the defaults. So to build that owl example that we looked at, here we define our colors as these Kotlin objects. So it's a color class where you pass in, here I'm using the long format to specify a color to create individual colors, constant colors. And then I put them together into these color sets using the builder function. So here I'm using the light colors builder function in order to build up a set of, for the yellow theme, set of colors for the yellow theme. Similarly, we model the textiles with a typography object, which accepts a number of these textile objects, which model almost like a text appearance from the previous system. And lastly, we do the same thing for shapes. So we have, a typed object which accepts shapes for the different types of shapes material understands, which it sorts into small, medium, and large components. So like that, you can pass in these customizations to get the theme you want. So for the owl example we looked at, we can create our own composable function. Here I'm calling it yellow theme. And that basically wraps this material theme function and passes in our colors, typography, and shapes that we want to use. So then using the theme is simple. So here's a screen, this onboarding screen, without any theming applied to it at all. You'll get just the default, what Material calls its baseline styling, lots of purple. And to get the styling we want, we simply wrap it in this yellow theme composable, and it applies the styling to all the componentry underneath. What's more, themes can nest or overlay as well. So on this screen here, which is largely a kind of a pink theme, has this related section at the bottom, which is blue. We can just add a nested kind of blue theme function here, and any content within that will then get the blue theming overlaid on top of the pink one. So I kind of asserted that Compose makes the easy things easy, and kind of this is kind of what I mean. Like the existing theming system in Android was always very kind of loosely typed. It was basically a bag of key value pairs. By giving a kind of concrete implementation of material design and using like strongly typed objects, you get lots of great benefits that we know and love from other parts of our code. Things like type safety and autocomplete. So because material theme colors returns that colors object we looked at with named properties, it makes it much easier to discover what colors are available and try and stick to this kind of smaller palette, which will make your application much more consistent. It also becomes much easier to do things like create derived colors. So here, because it's almost like a data class, you can just take a copy of it and change a value, like an alpha value perhaps, in order to get a derived color. Which makes it much easier to do things like theming, like supporting dark themes. And also because it's an implementation material, we can do things smarter because it knows that this is a material design system. So for example, we can default the colors that things use. So in this example here, I'm using this surface component, this blue background, which is set to use the primary color. Because the componentry knows the background is primary, it can offer smart defaults. So all text and icons by default will default to the on primary color, the color that should be shown on top of it. This isn't magic. It's just the fact that the text and icon composables understand that they are within a surface and that they can look up the right color to show on top of primary. And you can configure this if you need to yourself, but it gives you smarter defaults. And also we can make use of things like Kotlin's support for default values for parameters in order to make it much easier to find out what theming parameters our composables use. So here, for example, the Compose's floating action button has a background color, and you can see very clearly just from the method signature that it defaults to using color secondary for the background color. No more having to hunt through XML files and follow levels of indirection in order to work out what color something is and change it. Also, because I said that we model colors just as like an object, which collection of these colors, it becomes very easy to support different color schemes. So for example, I've said that we have light and dark color schemes. These are just a different kind of set of colors held in an object. And then supporting a dark theme becomes very simple. So here for the pink theme, I just have a Boolean parameter of whether or not to use dark theme. And then supporting dark theme just becomes an if. There's nothing special in here if you wanted to support multiple different color schemes in your application. It's really, really simple. Change it to a when. Cool. So hopefully that shows that it made some of the easy things a bit easier and safer. But it also makes things possible, which is quite exciting. This is one of our samples called Jetcaster, which is a podcast type application. And as you can see here, as you change the artwork of the selected item at the top, we extract a color from the artwork and use that color to theme the rest of the UI. So you can see the buttons and the tab indicator and so on changing color based on your selection. This was like really hard to do in the view system. To implement this, we use the existing kind of palette library to extract the dominant color from a piece of artwork. And then what we do is we look at the current color set and we take a copy of it and we override the primary color and use the color from the artwork to set it. We even animate this change, and I'm going to come back to this animate function in a little bit. Then we simply send this kind of updated color set to a new material theme, which we wrap the rest of the content in. And that's it. So you can dynamically set colors. It also becomes much easier to support custom design systems. Like while we ship an implementation material design, we think it's great for most people, you're not like forced to use it. So here's a design system from one of our samples called JetSnap, which uses a lot of gradients and different kind of color schemes in material. It looks a bit like this, and you can see even componentry like this button at the bottom has a gradient on it. To build something like this, you just do the same thing a material does. So you just model your colors as an object. So here's a class with different properties for the different semantic named colors in my design system. Now, you can't just pass this into the material theme composable because it doesn't understand this type. Like I said, it's a strongly typed system. But what you can do is just do the same thing that material does, which is to hold the colors in an ambient and then use them. But wait, I just introduced a new concept here. What's an ambient? So normally in Compose, you pass data downwards as parameters to your methods. But this can become cumbersome for things which you use all over the place. You don't want to define your colors at the top of the tree and pass it through every single function that you then want to use the colors or type styles. So ambients are kind of a service locator where you can name a value and look it up later. They're also tree local, so if you can override them at different positions in the call stack and have different values. So here's how you define an ambient. You basically use this ambient of function, and this associates the name of this ambient, JetSnap colors, to a particular value. Here we're giving it a default of this light color palette. Then somewhere in your tree, you use the providers composable, which is how you set a value for the position in the tree. So here we're providing a value, this colors parameter, to that named ambient. And then somewhere later, we can use the current property of that ambient in order to look up and retrieve that value. Here I'm wrapping it in an object to make it a bit easier. But basically, it means that somewhere in my code, I can now do something like this, jetsnap theme.colors, and then grab access to my type. So no longer the material color scheme, but this is my semantic design system colors. And you can do things like alter the componentry. So this is the material button that ships with Compose. If you look into the implementation, it's super simple. I've omitted a few lines, so it's basically about 30 lines of code. It accepts a solid color, but we want to have like a gradient background. So materials button basically is built by assembling 3 other composables, a surface to give the kind of background. It's a text style provider to set the typography style, and a row to arrange the content inside it. So what we can do is create our own button. So we just take the implementation of materials button, those 30 lines of code, and just edit it. So I'm going to rename it to JetSnap button, and instead of a single solid color, I'm going to model my gradient I wanted as a background as a list of colors. And I'm going to default that to a color from my color scheme. I'll keep using material surface, but I'll disable its background by setting it to transparent, and instead draw my own background gradient. I'll come back to modifiers again. So what I love about Compose is it's not a single monolithic library that you have to use all of it. It's built into layers. There's this runtime, then UI, then foundation, then material on top of that. So if you want to design your own design system, you can build it on top of material, or you can forego material completely if you like, and just build your own on top of the lower level layers. Within each layer, the same principle applies. So while the button component is a material component and knows about material styling and so on by being built up from these other pieces, you can build your own button using the same components as material uses, or dropping down into these lower level primitives and having no dependency on material at all. It's entirely possible to do that. Cool, so that was theming. Next up was layout. So our sample apps had a variety of different complexities of layouts. Generally, the basic layout managers were just super easy to use. So you have things like columns and rows, boxes for overlapping content, and even my beloved constraint layout. These were like more than sufficient for building all the sample apps. But one thing that really stood out to me is how simple it made some of the harder things to do in Android, things like lists. So this is the JetSnap application we saw, which is like a vertically scrolling list of horizontally scrolling lists, so a list of lists. Let's look at one of these horizontally scrolling rows. And this is how you build it. We have this item, this object called the lazy row. And this basically is the equivalent of a recycler view in Android. But this is all the code it takes to hook it up. There's no adapters. There's no separate XML layouts. There's no diffing and stuff going on. So basically, it's as simple as that. You give it a list of items, and it gives you a callback where it gives you a single item, and you render it. So the snack item is the layout that's going to render its individual item. But I also said it's a kind of a list of lists. So basically, we have this content here, which is vertically scrolling. But as you can see, it's made up of different content. So there's these static kind of filters at the top, and then there's a list of these snap collection objects. So this was always hard to do in Android because you'd end up with a recycler view with different item types or multiple adapters concatenated together. Compose offers a much better approach, I think. It offers you this thing called a lazy column. So what's that? So lazy column is a way of giving you this recycling type behavior. It'll only lay out the items which are on screen at any one time. And within the kind of the callback block, you're in a lazy list scope, which offers a few cool methods. So you can add a single item. So here, those filters, just an item, and they'll kind of get recycled off as they scroll out. Or items. So here you give it a collection of data items, so a model object representing each of those kind of scrolling rows. And then I just render each of those. And that's it. So there's no kind of multiple adapters or anything like that, just these really kind of smart scoped methods. Sneak peek, we're also working on a header method. So instead of an individual item like that, we'll actually have sticky header behavior, which is always really hard to do, I think, in regular Android. So I said the regular layouts were enough to build all the sample applications, but actually there's one part of the layout system which I think is really worth looking at because it really shows the power of Compose, and that's modifiers. So modifiers are how in Compose you decorate or add behavior to a composable. Let me show what I mean. Let's build up one of these list items from the center of the app here. So let's build this item here. So this is built up using those layouts I talked about. So there is overall, it's a row to lay things out horizontally, in which there's a image there and then a column containing two text items. But if you were to kind of like run that code just as it is, you'd end up with something like this, not quite what you want. And this is where modifiers come in. They let you configure the behavior of each of those individual composables. So every UI composable accepts this parameter, modifier parameter. And modifiers are all defined as extensions on the capital M modifier object, allowing you to easily find out what's available. So here, for example, in the image, I'm using a preferred size modifier to constrain its size. I can then add some padding onto the column holding the text in order to kind of move it away from it. But modifiers support this fluent syntax. You can keep on appending them. So here I'm adding an alignment to center it vertically. But the cool thing about this is a lot of modifiers are defined as extensions on particular scopes, by which I mean a row lays things out horizontally, you know, from start to end. So it wouldn't make any sense to use any horizontal gravities that would be fighting with the overall layout. So instead, row exposes this alignment modifier, which only accepts vertical alignment. So here I'm centering it vertically, but it would prevent you from trying to set a horizontal alignment. It just wouldn't compile. So no more trying different layout params and guessing which ones are going to work. Modifiers aren't just for layout. You can also use it for drawing and more. So here I'm applying a clip modifier to round the image. And modifiers are always the first optional argument, so you can always use it like this without having to name the param. If I want to add a background to it, I can append the background, a background modifier here using the surface color. But doing this might be surprising. You see, it's not filling to the edges of the item here. And the reason for this is that the order of modifiers is significant. If I want it to fill to the edges, I have to do it before the padding item, to draw before the padding item. This takes a little bit of getting used to at first, but now I think it's super, super powerful because it puts you in control of how different behaviors interact. It's not down to some internal implementation detail of an object you don't control. It's entirely up to you, and it's like deterministic as well. So if you want to add some padding, like around the item, a bit like margin before, you can use a different padding modifier. You can repeat them in the chain. And if you want to make the item interactive to tappable, you can add the clickable modifier like this. And you're in control of what, do you want that outer margin to be clickable or not? It just depends on where you put it in the order. You're in control. And then you read modifiers as like an ordered chain. So you say, you know, add some space around this item, then make it clickable, then draw a background, then add some inner spacing. You kind of read it like that, and you're in control of what happens to the item. And these are some fairly simple modifiers, but you can see, hopefully see how you can combine them to build up pretty, you know, a lot of functionality just by composing together different modifiers. And there's a whole host of different modifiers to explore. So if you want to add toggleable behavior, or make an item scrollable, or make something even zoomable, these are all available as stock modifiers out of the box, or you can, of course, write your own. Another element of the layout system, which I really enjoyed about Compose, is that it precludes you from measuring items twice. So back in kind of the view system, we were told to kind of avoid using, you know, nested, weighted linear layouts, or too many levels of a relative layout, because you can get into these very expensive, very costly measure cycles. And we just completely banned that in Compose. So if you try and measure an item twice, it actually throws an exception. And what that means is that you can now use layout in places that you would have been prohibitively expensive or potentially expensive before. So you can do things like you can scroll items and like have it layout based on that, or you can even do animations and animate layout attributes. And speaking of animation, animation has got so much simpler. So in this example here, when you select an item, it rounds the corner and adds an overlay. So to do the kind of this statically, you just do something like this. There's just an if it's selected, set this corner radius. And to animate it, it's as simple as adding a single function call around it. So you just add this animate method around it, and that is it. It's going to animate it like that. There's actually a bit more going on here. So you're actually you know, showing the color overlay and the tick. And so there's actually a different API I could show you called a transition, where you can actually coordinate all these animations together. Let's skip through this a bit quickly because I'm just about out of time. But one of the things I do want to show you is that we're also shipping great tooling to help you with this. So this is the animation inspector, which allows you to, in Android Studio, like on your host machine, look at this transition animation that you've defined, and like kind of scrub it, play it back at you know, slow speed, or individually scrub through the frames in order to tweak those animations and get them just right. What's more, we also have the ability to debug animations. To test animation, sorry. So you actually have control of the clock, which drives the animation system. So from your tests, you can pause the clock or advance it by particular times, and then walk through your tests. Like here, what I'm doing is I'm advancing the clock by a particular amount and then grabbing a screenshot in order to assert that an animation runs as I expected. Cool. So as I said, hopefully I've shown today that Jetpack Compose makes not only the easy things easy, but the hard things possible. We've got a ton of resources out there. So there's samples I've been walking you through today, a number of code labs, as well as updated documentation. And Compose is in alpha right now, hoping to go to launch to 1.0 next year. So we really want your feedback. Try it out and let us know what it's missing, what you want to see from it, or talk to us on Slack. That's it. Thanks very much.
Okay, Nick, it was a great presentation, and it was a pleasure to watch. And I have one question for you from our watchers. It's will we see paging tree library support with Compose?
Yeah, absolutely. We've actually already that's already landed. It's just not quite made it into the release snapshots just yet. We're just shuffling around the packages in. So yeah, that's coming very soon.
Okay, that's all, I think. No more question. Thank you for attending the DevFest 2020.
Thanks for having me. Bye now.